This is the review video for the first optics quiz. There are basically 4 essential facts you need to know. The first one is about the double slit experiment. So this slide here is showing you a picture of a laser shot through 2 slits that are very close together. The fact that we see these various bright spots means that the light diffracted. So we're seeing light undergoing diffraction. Diffraction, as is classically understood, that means kind of before we started getting into the quantum physics that came out of the double slit experiment, but as classically understood, only waves can diffract. So if something diffracts, so if diffraction, then it must be a wave. So the double slit experiment, as shown here, proves that light is a wave. Now there are other ways to conduct the double slit experiment. For example, if you were to locate or isolate a photon, which is a particle of light, so light is also a particle, and shoot it through the slits, we would see dots appearing. So we also know light is a particle. But as performed, the double slit experiment shows that light has a wave nature. And if you're ever asked to defend that answer, you would say, we're seeing diffraction, and diffraction is a wave phenomenon. So light is a wave because diffraction is a wave phenomenon. So if you're ever asked to say, how do you know light is a wave? You could say, in the double slit experiment, light diffracts, therefore light is a wave because diffraction is a wave. Phenomenon. Phenomenon just means thing that happens. Next up, you need to be able to recognize the wavelengths of common colors of light if they were given to you in a number kind of by itself. So on our visible light spectrum, which I'm showing the entire electromagnetic spectrum, right here, visible light, we've kind of zoomed in from here. Violet, the lowest wavelength, highest frequency, happens at 400 nanometers. Red happens at 700 nanometers. So if you get light somewhere in the 400s, you're looking at violet or blue. If you get light in the about 500 nanometer range, I think it's actually like 550 for green. But if you're given a number of wavelength of light that's in the 500 range, it's probably green or yellow, but we're at the green primary color. And if you're given something that's near 700 nanometers, you're at red. One thing I do want to say, I saw some people kind of freaking out about the fact that 4 times 10 to the negative 7th is the same as 400 times 10 to the negative 9th, or 400 nanometers. Think about it like this. If I wanted to make this into nanometers, because that's our common kind of way of discussing light, I need to make the exponent a 9. Well, if I move my decimal to the left, someone else would have to move to the right to go back. And you tell somebody else to move to the right using a positive number, so I have to change this to a negative 6. So that doesn't work. But if I move to the right, I've got to tell somebody else to move to the left. The way I do that is by increasing a negative number in the exponent. And so 2 to the right that I moved would be 2 to the left that someone else would move. And so it becomes 2 more negative, or negative 9th. The wave speed equation still applies to light. It's for all waves. If you were in a double slit problem from d sine theta equals m lambda, if you found lambda, you could then find frequency, because the speed of light in air, so as long as this double slit experiment was conducted in a lab with air in it, speed of light in air is 3.0 times 10 to the 8th meters per second. And so from that, you know v, even if it's not said in the problem, you should have memorized the speed of light. Lambda you just found from the experiment, and now you could find the frequency of that light. One other thing, the double slit experiment can be conducted with more than one colors at once, so we can shine white light through double slits and get a diffraction pattern. In that case, what you do is calculate this equation for each wavelength. So there might be short wavelengths, like red. Sorry, red's a long wavelength. Short wavelengths like blue. and then you would calculate everything for where your red is going to show up, and you could calculate everything for where your green is going to show up, and then for your blue, you're just swapping out the wavelengths for those different colors of light. So the point is there, you might be asked a problem where they're shining more than one color through a double slit experiment, and you just have to read the problem and pick out which lambda you're talking about at a given time. So they might give you several lambdas, and you just have to be able to process through the question. They say if it's the short one or if it's the green one, you have to know which lambda to pick. Okay, so I've got kind of a simplified drawing of a double slit experiment. One of my lines disappeared. Happening here, got a laser with a diffraction grating, so a bunch of lines, and a screen that we're projecting onto. You may be asked to find the distance between two dots. So let's call that distance x. That distance is not in the equation d sine theta equals m lambda. The d here applies to the diffraction grating. It's the distance between the slits. So d is distance between slits. That was terrible handwriting. But d is distance between the slits. It is not the distance between the dots, and I saw a lot of people making that mistake in the lab. D is not the distance between the dots. That distance does not appear in this equation. What does appear, though, is the sine theta between the dots. So there will be a consistent angle between the dots. And that angle is the same between any of them. The reason that angle changes with m, though, is because we're always measuring the distance between the center dot and the mth dot. So if I wanted the angle way out here, that would be m equals 2, and this angle, if drawn correctly, should be the same as the first one, which means that there would be 2 of those thetas from the 0th dot to the second dot, and that's what that m takes into account. Anyway, if you were asked to find this distance x, you would need to use the length to the screen, let's call it L, and this angle, and things you know about triangles, trigonometry, to find this distance x. And you can do all that. That was actually one of the problems on your pre-lab, so I'm not going to work back through that because you should have already done it. But the idea is, if you're asked to find the distance here, you have to recognize that that distance is not in the equation. It is most certainly not d. And I will laugh at you if you call it d, and I will also feel very sad because it will mean you didn't watch this video. But you can find theta from this equation right here. And a problem would have to give you L or some way to find L, the distance from the diffraction grating to the screen. And then you could use trigonometry, or the geometry of this triangle, to find x. One thing I do want to throw in, sometimes the way this is phrased on an AP exam is they'll say, at what position x? And it might sound like they're asking you to pick, because it kind of makes it sound like they've given you a list of positions and you're picking one. But what they mean is, when they say at what position x, they're telling you call the 0th dot the origin, or they'll give you some other place from the origin. So the way this would probably look is they would label like from here to here and say we're going to call this a distance x, and then ask at what position x. So they're telling you to use the 0th dot, the middle dot, as the origin. Or they could specify somewhere else, so they could really make this complicated and say from here to here is x. But that would be kind of confusing. They'd have to give you a lot of ways to figure out like the length of the screen and such. So most likely what's going to happen is they're going to label a space from the 0th dot, the middle dot, to another dot, and then tell you to determine x, that distance. But the way that they might phrase it is at what position x. So just know that that's asking you to find the distance x using triangle geometry.